Right, this is for grade 11 and 12, a circuit problem, a little bit more complicated problem. It does not involve any internal resistance. Now, what do we have here? We have a circuit in which they say that whether the switches are open or both closed, the ammeter reading remains the same. So if the switches are open, we actually have a simple series circuit where the current flows along this line. So it does not branch, there's no parallel or anything, it's simple, it's a series circuit. So the first question is find the reading on the ammeter. So to find the reading on the ammeter, we can simply use our Ohm's law, V equals IR. Before that, though, we need to calculate the total resistance. So R total equals 6 plus 1 plus 2 equal to 9 ohm. Right, and then we can work out V equals IR. For this, we're going to work with the total voltage, the current through the 6 ohm resistor, and the resistance that we just calculated. This is now for the series circuit. Okay, so 4,5 equals I through the 6 ohm times 9, and that is equal to 0,5 ampere. So I can now indicate on my sketch that the current flowing in this branch is 0,5 ampere. Reading on the ammeter, therefore 0,5. The next question is for 6 marks, resistance of R. In this question, we're going to have to use the fact that we can now close the switches, both of them, and then the circuit changes to a parallel circuit. If you follow the current from the battery, it's going to reach this point. It's going to split that branch and that branch. It's going to go around and join again here. If that switch is closed, no current is going to flow through the 1 ohm. It is simply going to go back to the battery via the 2 ohm resistor. So that's the circuit splitting there and joining there and going through the switch, that short circuit. Please remember that no current will flow here because the current takes path of least resistance. Therefore, we can calculate in 12.2.2, going to calculate the voltage over the 6 ohm resistor first. Voltage over the 6 ohm, so that I can know how much volts I will have, how many volts will be over the R, and therefore I can also work out the voltage over the 2 ohm. So it's going to V equals IR, 6 ohm, 6 ohm, 6 ohm. So I'm going to work out the voltage there. I know that the current through the 6 ohm is 0.5, I just calculated that. Resistance is 6, therefore 3 volt. If I have the 3 volt over the 6 ohm, I remember that in parallel I have also 3 volt there, and the rest of the volts will be over the 2 ohm. So the voltage over the 2 ohm is therefore equal to 4,5 minus 3, which is equal to 1,5 volt. I have used the fact that we have voltage dividers. Right? If I then have the voltage over the 2 ohm, I can work out what the current is over the 2 ohm resistor. Because I have the volts here, I can then work out what the current is. So V 2 ohm equals I R, and I will be my total current, and the resistance will be the 2 ohm. So the voltage I just worked out is 1,5 equal to I total times 2. Therefore, I total works out to be 0.75 ampere. That helps me a lot because now I know that my current here is 0.75 ampere. At this point where it splits, 0.5 flows there, so the rest of it must flow here. So I can now work out what is the current through R. Current through R is 0.75 minus 0.5 equal to 0.25 ampere. Right, I already know that the voltage over R is 3 volt. I now know the current, so therefore I can calculate R by again applying V equals IR, but now it is through R, current through R, the resistance of R. Now I just fill in my values, 3 volt, 0.25 R of R, and therefore R works out to be 12 ohm. And that answers the question.